So for today, like I said, we are focused on our part 2 of reducing embodied carbon in design, process, and strategy. We're going to start off with Chris Chatto, who's going to talk about the life cycle assessment journey. Baha Sadreddin will then talk about the LCA workflow throughout the design process. And then Michael Cropper will end with an overview of some embodied carbon reduction strategies specific to structural engineering. All right, I'm going to kick it off to Chris. Go ahead.
Okay, hi everyone. Hopefully you can hear me again. So my name is Chris Chatto. I'm a principal at ZGF. I've been at ZGF now for just about 15 years. And while I don't have the same deep expertise as the other two speakers in terms of actually doing the life cycle assessment, and that's what I'm hopeful they're going to be able to provide. I work with Baha closely on our LCAs. I do have a lot of experience working with our clients, really focusing on carbon holistically and embodied carbon impacts on our projects. So I hope to provide a little bit of introduction in terms of how ZGF Architects has started doing LCAs, what we've learned from the process, how we're working with the LCA process to bring value to our projects and our clients. Let's see if you can go to the next slide, please. So it falls on me to do just a sort of a basic introduction to LCA. Most folks probably know this, but if you're new to the group, it might be a little refresher. We're using LCA, not life cycle cost analysis, but life cycle assessment to look at the materiality of a building, to look at its environmental effects, air pollution, water pollution. We're really focused on climate change and global warming potential impacts. To identify, where the impacts are in a building construction and hopefully optimize and reduce those impacts. And hopefully we get to a point where in our industrial economy and architecture, we can get to zero carbon or close to zero carbon buildings. Go to the next slide. You've probably, a lot of you have seen variations of this graph. We used to say building operational energy use, something like 40 to 50% of global greenhouse gas emissions. When we do a finer slice at it, really look at, what's driving building carbon usage, the embodied carbon of buildings. And so this is the global warming associated with the construction, maintenance, materiality of our buildings is about 11% of the global pie. So it's a significant part of the problem. And if we go to the next slide, we look at existing building stock. So if everything we started building, say, as of last year, for those projects, the lion's share in that first year, of course, is actually based on the construction of that building, all the concrete, excavation, materiality, and then the operational carbon will increase over time. This is important for a couple reasons. I mean, most importantly, we have a limited amount of time to address the global climate crisis. We have targets in 2030 and 2040. So if we look at buildings that we're thinking about now for our clients, we have to recognize that even over their lifetime, if operational carbon might be higher, embodied carbon right now is the most urgent. And of course, the strategies that we can do in operational carbon, particularly if more and more we're seeing all electric buildings, the grid is getting cleaner, the embodied carbon will still be an impact and something we need to address. If you go to the next slide. Yep, so I think I just talked through the animation here. So yeah, so for the next 30 years, operational carbon is a big part, but embodied carbon is also significant. If you go to the next slide. So over the next 30 years, embodied and operational carbon for these projects we're building now will be roughly equal. And if we look at the next 10 years, as I said, the preponderance is going to be on the embodied side. If you go to the next slide, please. Yeah, so over from a 2050 for those projects, and if the next slide, we'll see that in the next 10 years, embodied carbon is the majority for these projects we're designing now. So we need to do something about this. ZGF has been a signatory of 2030 commitments since 2010, and we've signed on to the structural 2030 challenge as well. So it's something we're committed to. And so we'll talk a little bit now about some of those projects and how we're addressing it. If you go to the next slide, please. So the first project that we actually did a full whole building life cycle assessment is this office building. It's for the state of California. It's a really interesting project. Sort of a design build competition with performance, incentivized performance metrics to essentially make this building net zero energy. It's doing that through offsite utility scale arrays at this scale, and it's in downtown Sacramento. But you know, as part of the winning bid to win the project too, we pledged to get the project to LEED Platinum under LEED version 4, and to do that, we obligated ourselves to do a life cycle assessment. So this is for the LEED MR1 credit, and really a little bit out of our skis because we hadn't done it before, but we were confident we could get there, looking at some of the best practices to reduce embodied carbon. If you go to the next slide. So before we even had a whole model of the building, and before we had been doing whole building LCAs, and I'm sure Baha and Mike will talk about some of the tools, I use this very simple tool by Athena, EcoCalculator, a free tool, just to pick, you know, essentially a concrete building in the California region and understand what was driving the global warming potential in the pie chart down there. And what you can see with foundations, footings, columns and beams, and the floors, and we ultimately were, this is example is a post-tension concrete building, and we're doing that because floor-to-floor heights and the overall height of the building were an issue, and the client wanted to get an extra floor within the Sacramento height limits, and this was the best structural system for that, and for a number of other reasons. This tool helped us identify 4 core and shell structure, and really just isolating structure and exterior walls. The structure was essentially 75% of the impact. And of course, the majority of that would be concrete in the footings and floors. And so this really put a target on concrete and to say, if we're going to achieve a LEED reduction, and at the time we were using LEED version 4, where the only points available were for a 10% reduction in global warming potential, as well as some other impacts, we needed to essentially reduce our whole building LCA for core and shell by 10%. So if concrete is roughly 75% of the pie, we needed to reduce concrete by at least about 15% to scale over the whole building to get that 75% reduction. So this kind of gave us some marching orders to really target concrete and look at ways to improve upon the baseline regional practices. If you go to the next slide. This is ultimately what we achieved. We hit overall a 14.7% reduction in global warming potential. And again, the large majority of that is based on the concrete and the structure. When we sort of iterated different concrete mixes into the Revit tool, if we were using Tally, which is a great tool, you know, we noticed it was a bit of work to open up the Tally model, input concrete mixes, and be able to see how it compared. So we developed a faster way. We kind of developed, and Baha was doing this analysis, we talked about creating a separate spreadsheet so we could actually more quickly test concrete mixes. I think if you go to the next slide here. And so we developed this LCA calculator. It didn't look this nice the first time through, but Baha did a lot of work in terms of making it look good. I just lost the video. I don't know if others did too.
I did too.
Sorry, my PowerPoint crashed. Let me see if I can bring the file back up.
Okay, at least Zoom's still going. While you're doing that, I'll talk a little bit about the tool. So yeah, we just developed this Excel tool, and what we were doing is essentially in parallel with the data in Tally, we kind of created the baseline data and we're able to basically put together a tool so we could input proposed mixes and really compare it to the Tally database within the Excel tool. And what that did is it took something that, you know, might take half an hour to fire up Tally, enter the stuff, run an assessment, and we could do it in a matter of minutes. And create a tool also, yep, so great, I can see it now, create a tool that we could share with the contractor and concrete suppliers. So this got me, now I've had, with multiple projects, had conversations with concrete suppliers, talking about the tool, and this was a number of years ago. So there were fewer EPDs for concrete, but this was in some ways an EPD for free that allowed us to, you know, take a concrete suppliers mix. And what we're doing is comparing against the NRMCA mix for that geographic region. And for specific strength, NRMCA reports based on all their members what a typical mix in that region would look like for that strength category. And then this tool actually takes both that NRMCA baseline mix and your proposed mix and uses the life cycle data in Tally to run the LCA comparison. So it's not actually specific to, you know, that local supplier's activity is certainly not as good as a local EPD that's, you know, verified and really reflects the local practices. But for any one supplier, and because this is a design build project, our contractor developed a relationship with a local supplier who supplied the job. We were able to work iteratively with them to find mixes that you know, were cost effective, but also met our LCA targets and could easily you know, find better mixes. And there were a number, we've seen numerous benefits on projects now. A lot of times people are doing shorthand, you know, percent SCMs or supplementary cementitious materials. And this, you know, sometimes we found at least one situation where we asked for more SCMs and the supplier came back and gave us more fly ash and slag, but didn't actually reduce the cement content. So the percent SCMs increased, but actually the global warming potential of that mix actually increased versus decreased. So this tool was actually more of a neutral playing field. We could compare, make a relative comparison for any one supplier to find better mixes and align it with ultimately the data that's coming out of Tally. So really helped us achieve that LEED credit and really sort of open the door to where we're saying, wow, concrete's such a big impact in the industry. You know, roughly 8% of world's global warming potential worldwide is due to concrete. So we should be focusing on every one of our projects, whether or not we do a whole building LCA. So if you go to the next slide. So this is a regional project for you all. I'm on the West Coast, but a project our DC office is doing it. It's, as you can see, almost 2 million square feet of office space, great amenities for the people who work there, have lots of dogs, have lots of events. Can't tell you, it's a confidential client, so can't tell you who it is, but a client that was interested in a holistic approach to carbon, had made some carbon commitments. And so, you know, as part of that, and as part of the LEED strategy here, in addition to everything we're doing on the operational side, all electric, clean powered building, wanted to optimize and reduce carbon emissions associated with a concrete structure here, and with the significant foundational and underground garage elements. If you go to the next slide. So this was a really interesting process. We ultimately turned over our LCA concrete tool to the project sustainability consultant that we were working with, and actually gave our tool to local concrete suppliers. And we actually had 2 different suppliers. It was a big enough job. One of them actually had a nearby plant, and one of them actually set up a batch plant on site. And actually we saw with both of them reductions, more significant global warming reductions in the batch plant. I think the proximity to the project site allowed them to push the mixes a little bit more in SCMs and was a little more successful. But both of them, using that tool and in concert with a whole building LCA, achieved significant reductions. And I do want to point out that carbon cure was part of the mixes for both suppliers, achieved roughly a 5% reduction in global warming reduction a little bit lower, as you can see, than compared to what we did with the specific mixes in terms of reducing cement and increasing supplementary cementitious mixes like fly ash and slag. You go to the next slide. So we, as I wanted to talk a little bit about how we're sort of taking this to scale, and one of the things actually we just released at ZGF is a material playbook. And this is something for all of our teams. There's a lot more information about LCAs, EPDs, environmental product declarations, health product declarations in terms of material toxicity and effects on human health. And so part of it we want to do is give a guide to our project teams and how to address concrete. And so really our best practice right now is to, really depends on which ideally we're starting before a concrete supplier has already been selected. But in a number of cases with projects going on, have started already. Sometimes we're coming in later, and it's a different path. But for those that haven't started or gone to bid yet, our process really is to use EC3, which a lot of folks I'm sure are familiar with, to check to see if local suppliers have EPDs. Because if they do, and we can create a competitive environment, we can actually specify global warming limits based on the available local data. And that's a great process, and we're doing that on projects. For other ones though, where their EPDs aren't available, we're working with the local contractors and are providing just from our tool, our NRMCA global warming potential cement content limit or global warming limit, and asking that they provide mixes that can be better than that regional average. So it's a little bit flexible depending on the context. And I've worked now, we're looking at projects on both coasts, but also in the middle of the country. And certainly areas like Seattle and San Francisco, I think are maybe arguably leading the country in terms of the cement suppliers, concrete suppliers, and other locations have a little catching up to do. So we really have to tailor our process based on what's available. Go to the next slide, please. Oh, so yeah, I was talking about those two things, but we'll just move on. So one of those East Coast projects is at Princeton. They're expanding their campuses and new central utility plant, pretty exciting. It's going to be zero fossil fuel, use thermal balance, and ground source heat pump to supply this new campus. A lot of heavy athletic facilities, but other elements too. And as part of that, we are using this process and working with a local supplier really to identify a mix that has fly ash, slag, and Portland limestone cement for an optimized reduction in concrete. You go to the next slide. And as part of that, we really surveyed all the available technology, and there's a lot out there. A lot of folks have heard about Carbon Cure, Blue Planet, actually, and you can see for all of these strategies down below, these pie charts really show you in dark green sort of what we've seen in terms of verifiable reductions, in light green what conceivably is the upper limit. And so a lot of folks have heard of Carbon Cure, and that can make an incremental benefit. There's other alternative cement mixes or processes that will sequester additional carbon, potentially be carbon neutral, and looking at a lot of SCMs and starting to track these and seeing that in some markets, at least, they're starting to get introduced, and really excited for a lot of innovation on concrete coming forward. If you go to the next slide. Just want to talk about a couple of examples how we're using LCA. So, whole building LCAs are great. They're, aligned with a LEED credit, which can be really helpful. But we've also found that a lot of times we're doing those really late in the process. By the time the project has enough specificity, by the time the Revit model is built, with accuracy, and the time taking to do an LCA study, it often happens a little bit later than we can influence product selection. Concrete being a notable exception because it really comes down to the mix. And so that is something that we can do a little later. But if we're looking holistically at what's driving carbon mix, this idea of doing a bay study, or in this case, this is an apartment building. This is also a regional project in the DC area. Client was very interested, seeing the future of the market, understanding where the building industry is going in terms of doing, addressing carbon, potentially operationally carbon neutral. And it was just a next step to look at embodied carbon, particularly that at least one carbon neutral certification under ILFI controls both operational carbon and embodied carbon. So this apartment study, looking at just one unit, really helped us, focus on what were those things over the 60-year life cycle of this building that are going to be driving carbon. Again, concrete, big part of it. Enclosure is significant, but not nearly as significant as interior walls. And so this model really informed, if you go to the next slide now, what, some strategies, whether it's looking at the interior partitions and ways to use a lower impact wall assembly to make a significant dent in the interiors and to the overall embodied carbon. If you go to the next slide. We also looked in Tally, looking at different envelope options. Ultimately, actually, we ended up using a tool that PAE has developed that's online, it's free, it's called Kaleidoscope. So this is, to say, again, whole building LCA is really important, but sometimes these quicker tools, allowed us to pick 5 different options that we were looking at and get a good sense of not even just the relative carbon impact of them, but also what was driving that specific carbon impact, and to understand how we might even be able to improve that. So we're working with that right now. And the next slide, I think, looks at, actually, I'm not sure. Oh, okay, so yeah, last project example. And this is really kind of tying in using LCA holistically to meet, this is the West Coast Healthcare Institution that had committed to operational carbon neutrality. And as an ongoing client, we started having conversations about holistically looking at carbon throughout their portfolio. And so looked at a medical office building project we were doing for them. Project is still in early design, but looking at this to sort of benchmark a prototype building and understand what's driving carbon emissions for this typical building type for them. We go to the next slide. So we kind of mapped out all the areas that are driving carbon, scope 1 and scope 2, all the energy use of the building, refrigerant leakage, the building, but also the scope 3 emissions. So the building construction, site elements, both excavation and hardscape, but also the potential sequestration of trees, and then also what transportation impacts would be as well. So if you go to the next slide, please. So it mapped out a couple different scenarios, a baseline or a typical Northwest grid, and then started to look at different scenarios to reduce that. One, whether or not we're going to take responsibility for the patient travel. I mean, I'd argue that it's part of the selection criteria of a MOB, but also recognizing we need to have MOBs that are accessible to everyone, and some places are just going to be a little bit more auto-dominated, like this location. But also reflecting this local utility, which actually was in the Northwest, heavily hydro, so reduced a lot of our energy emissions, and then what we could do to optimize that. So from a typical building in the Northwest, almost a 75% reduction in metric tons, and then really what was the best we could do, and really cut that in half again by a set of strategies. So we're still working with the client, but a lot of this work has sort of reinvigorated a conversation about what would be a mass timber medical office building, which would be really exciting, and looking forward to taking to the next step. If you go to the next slide, please. And just an example of how we were looking at just a couple typical building elements to highlight what we could do, how wood might be able to help us, particularly sustainably sourced wood, cut the carbon emissions by about 25%, a range of options for envelope and what might be the better choices there, And also recognizing, looking holistically at the life cycle of this building, that depending on the amount of churn and revisions and renovations in the interior, that could have a really big impact over the life cycle of the building in carbon. So hopefully we'll actually, as we get into more detailed stages of design, positively influence the way we think about interior renovations and reducing the need to, tear down walls, throw away gyp, et cetera, and make the building more flexible over the lifetime. So, so my kind of 3 recommendations for folks, one is like, find the hook with your project team and the client, whether that's driven by LEED, and we've had a lot of projects using the LEED whole building LCA as a way to get into this. We also have a lot of clients with greenhouse gas commitments. The ZGF works for a lot of institutional clients, so universities, we're seeing healthcare systems, also, some in the business world, big companies, tech companies. So we can make a connection between doing LCA and their carbon commitments. And then, finding both useful and time efficient ways to integrate into the current system selection process. The more LCAs we do, the better we get at them in terms of finding the right answer and not spending too much time, because it can be a rabbit hole. And I guess that's my second point, to really focus on effectiveness. Whole building LCAs, are important, but we can often move the needle, and whether that's focusing on concrete or other high impact materials. As architects, understanding envelope is incumbent upon us. We can make better choices there. And then, I think you'll find what we found is the more we do this, the better we get at it. We can continue to improve. So we've really committed to, not even just sharing what we learned within ZGF, but, sharing with the industry. It's really important. It's one of the reasons we are, do talks like this, and share, also are sharing our concrete tool, which I believe someone put a link to in the chat. So thank you. I think that was Rachel. Appreciate that. And so that's my last slide, and I'll turn it over to Baha to actually talk about how we do life cycle assessments.
Perfect. Thank you so much, Chris. So I'll be just complementing what Chris discussed to focus on LCA workflow. Next, please. As Chris mentioned, there are a few different drivers on how to get to, doing more LCAs for us, especially, the last couple of years. LEED has been a big driver. Next, please. LEED, if you guys are aware, LEED V4 had the, option 4 for whole building life cycle assessment credit had one threshold. A 10% reduction would get you 3 points. Next, please. And in LEED V4.1, the changes were really, impactful, where, you kind of get different steps, or you are guaranteed 1 point by doing an LCA. You don't even need to create a, baseline model. You could just do your proposed LCA to get into doing more, and you get 1 point, no matter if you show a reduction or not. You could show a 5% reduction in global warming potential and 2 more environmental impact categories and get 2 points. You can get what you would used to get under LEED V4 and show a 10% reduction in GWP and 2 more categories and get 3 points, or 20% in building reuse and or salvage materials and get 4 points. Next, please. And if you guys are aware, even if a project is pursuing LEED V4, you could still upgrade to LEED V4.1 on a credit by credit basis. So you could only upgrade this credit to V4.1. What is an effective LCA workflow? And then really my presentation focuses on LEED. As I mentioned, LEED was a driver, but it also creates some boundaries in terms of how an LCA would be accepted for LEED. Next, please. An effective workflow, and we could press the next button. An effective LCA workflow starts early in the design process, but it needs to continue throughout design and construction. So we need to start early to be able to have high impact, but up to the end of really right before construction, when you're pouring your concrete, you could still have impact. we had an example where a day before a floor plate was being poured, there were some issues and we had to change a mix design. Now, this could be a challenge, but this could also be an opportunity. So you could start early, have really high impact, but up to the late into the process, you could still have impact, specifically on concrete, I would say, which is a really high impact material. Next, please. It's a collaborative process. You need the support of the design team, structural engineers, consultants, contractors, and suppliers. It's everyone needs to come together and work together to be able to have an effective process. Next. It's an emerging practice, and the process is not perfect. As you do more LCAs, you realize that a lot of the data sources might be very different. You might run an LCA in one tool and get a very different number in another tool. That's one of the reasons maybe the ZGF concrete LCA tool uses the same LCI data for baseline and propose. So it's not perfect, but we just need to do more of it for the process to be more refined over time. Next. In terms of tools, there are many different tools available right now. Tally, One-Click LCA, and Athena are cradle-to-grave examples. We use Tally internally. There are also other tools like EC3 or many, other, the tools that Chris mentioned. And some of those are not cradle-to-grave at the moment. For LEED, you need to use a tool that is cradle-to-grave. Next, please. I'll go through a little mini case study to talk about workflow now. Next. The purpose of the LCA is to identify identify high impact materials and then either optimize them, use less of them, or replace them with lower impact materials. Next. When we get started, prior to doing a whole building LCA, which is what LEED would require, it's really effective to do early design assembly or bay model studies. Whole building LCAs give you the larger image, but you could always do a smaller study and multiply it by area, or just understand the effectiveness of one material or one assembly. And usually by the time that your, let's say, Revit model or building is to the point where you could do a whole building LCA, it might be too late to do optimizations of assemblies. So start early with smaller models. Next, please. It is actually from the example that Chris showed. For instance, in a multifamily residential building, you could start with a unit and you multiply it by the number of units that you have. But even within that unit, you could divide it into interiors, the envelope, or the structure, and really understand the impact of these different assemblies. Next. When we get into a whole building LCA, and this is an animation, we could just go through it as I speak. In whole building LCA, Revit design options are a little difficult to work with now. So when you do bay model studies or assembly models, design options are easy to work with. For instance, Tally has a design option comparison workflow that you could just run 4 different assemblies and see the impacts. When you get into whole building LCA and you have thousands and thousands of elements, it's really hard to create multiple design options with the whole assembly now. Next, please. This is where you could really focus on creating detached models and work sets for whole building LCA management. Next, please. The images I show is from one of our projects on the West Coast, the California Air Resources Board, building net zero office and lab, around 420,000 square feet. Next, please. So when we start a whole building LCA, we basically want to divide the model into structure. Next, the structural model and then the enclosure model. After that, you could also include interiors. For LEED, you're not required to include interiors, but optionally you could do it. And hopefully over time we get to do more of the interior models too, because it could be high impact. But the minimal would be to have the structure and the enclosure. Next. Within the structural model, typically the most accurate model is what you would get from your structural engineer. So I really highly recommend using that model. You create a baseline model and you create a proposed model, basically just duplicating the two. Next. And the same would apply to your enclosure model. You would create a baseline model. Next. You could create a baseline model and a proposed model. And then eventually, next slide, you link the two, the baseline enclosure and the baseline structure to each other. You create your lead baseline and your proposed structure and proposed enclosure, and you create the lead proposed model. Now, the reductions would be from the baseline to proposed, basically the 5%, 10%, or 20% that I mentioned. Next. For work set management, I think the bare minimal number of work sets to create would be to have an exterior work set, an interior work set, and a structural work set. The structural work set, again, would be the structural model. The exterior would be your enclosure, and then the interior would be anything that goes on the inside. Now, your company or your firm might have a lot more than what we see here. This is just a bare minimal. It's better to have more. But as you see on the bottom right of the screen, in Tally, you could filter a whole building LCA by categories of families, ceilings, and everything else, but also by work sets. When you filter by categories, let's say a ceiling that is in your, if it's, let's say on your structural model by accident, you can't really filter it. But by filtering through work set, you could really choose what to include and what not to include. So I highly recommend using work sets. Next. And when to detach a model. This is a little bit of a tough question because as I mentioned, you need to have your baseline model and your proposed model. The second you detach your model from the central, your changes are not reflected anymore. I really recommend, again, to do baseline or to do bay models and assembly models early on, but keep the model attached. And then you could start with your proposed design and really, add all the material properties in Tally and then detach it to create your baseline. So you create your proposed, add maybe 80% of the materials and then detach it and add the other 20% that might be changing from baseline to proposed. Next, please. This is just what I went through. Basically, you could when you detach, you could start with your baseline proposed. I recommend doing your proposed model so you have an understanding of what's going into the building. You fix all the issues within that one model, naming convention, and everything else that I go through. So before you duplicate the model, so you don't have to do the work twice, and then assign all the materials, and then make a copy to create your baseline from the proposed. Next, please. In terms of material optimization and documentation, next slide. I think it's really important to focus on focus your LCA documentation, at least for lead, on high impact materials. Sometimes because the modeling side of things between baseline and proposed is difficult, sometimes you might be making an optimization, which is really good for carbon, but it might be just, let's say 0.001% of your total impact. So I still recommend making that optimization in real life. So you make your design better, but you don't necessarily need to document it because it might take many hours for documentation. So it's a very low impact. You don't necessarily need to document it. Next, please. Material naming conventions. Tally recognizes materials with the same name. We could go through the slide. Recognizes materials with the same name. So you could really optimize your naming convention. Let's say if you have 10 different assemblies that have a type of insulation within them, just make sure that you use the same name. And when you apply the properties to one, Tally would ask you if you want to apply to all the other 10, and it'll save you quite a bit of time. So naming convention is very important. Next. I'll go through a few materials that might be a little either high impact or hard to, or important in terms of how we manage. Concrete, I keep mentioning concrete because it's a really high impact material. for naming, the strategy that we use is we say, let's say concrete dash application dash the strength that we use. Now, typically before doing LCAs, we would just say concrete, and then all the concrete within the building would be just one material and really hard to assign within Tally. Now we would say in a lead LCA or any LCA optimized workflow in Revit, we would say, let's say concrete dash slab on grade dash 4000 PSI. And this, when you run Tally, this would, you really just see the name of the material. Now this tells you what the application is, but also tells you the strength. So it's really easy to find the baseline and assign the properties. Next, please. And within Tally or other LCA workflows, I know Tally has the capability to do a custom mix design. I really recommend using the custom mix design, and you could use the ZGF Concrete LCA tool to convert the ingredients to, I think Tally takes kilograms of ingredient per cubic meter of material, but it's a column in the ZGF LCA tool, so it's automatically done for you. I really recommend using the custom mix. Otherwise, using the large ranges, you might not really, let's say if you use the 2501 to 3000 PSI example, it might not really represent the savings that you are getting. Next, please. Studs are a little challenging because, as you know, in Tally, in Revit, they would just be a solid 6-inch kind of cavity. But in terms of naming, I would recommend using the type or material dash the spacing dash if you have insulation or not, and the type of insulation. For instance, studs dash metal dash 16-inch dash bad insulation would give the kind of LCA practitioner all the info they need to fill out the details. Next, please. And in Tally, again, you get the option to choose the materials. You choose the, the type of stud, the gauge, and then the spacing. And you could choose insulation if there is insulation in between. Next. The last, sorry, this is also an animation that I forgot about. The next one, or the last one that I'll just quickly touch on are mullions. As you know, in Revit, mullions are just modeled as solid. If it's really important to make sure that in Tally, we choose the correct profile and the correct thickness or gauge. Otherwise, your aluminum would be drastically over accounted for. So mullion dash material dash size, really that's a good example of 2.5 inch by 4 inch, and you have the thickness of the material. Next. And this is an example of what you'd be able to assign in Tally. Next, please. This is my last slide, I think. Now, this is a common question that we often get in LCA presentations: how to integrate changes into a whole building LCA Revit model. And the answer is that it's just really hard to integrate changes into a whole building LCA. So again, the best workflow would be to start small with assembly models and bay models. So by the time that you are doing your whole building LCA, you've already figured out many of the details, and it's less likely that you need to make changes. The second, as I mentioned, is to detach your model as late as possible so the changes are reflected. The changes in the Revit model are reflected into at least one model, and then you detach it and create the baseline or the proposed, or vice versa. And then the last one, if you really, there's obviously cases where changes happen and we haven't thought about them before. I still recommend using the model that you created and just copying and pasting elements from the new model into the existing. And if you use the same naming convention, they would be automatically updated in Tally. Now, this might be difficult, but it's really the only way to make the changes. Yeah, hopefully this was helpful. I'll pass it back on to Kristen. Thank you.
Thanks, Baha. We're going to pass it on to Michael to talk about just an overview of some embodied carbon reduction strategies.
Yeah, hi everybody. I'm Michael Cropper. I'm a senior associate structural engineer at Thornton Tomasetti in our Washington, D.C. office. I'm coming at this from a structural engineering perspective, and embodied carbon is new to me in the last 2 years or so. I've been at Thornton Tomasetti for 14 years, and the whole embodied carbon reduction is new to me personally, but we've been involved with tracking and evaluating embodied carbon for the last 10 years on our sustainability side. So I'm coming at it again from a structural perspective. So let's get started. Next slide, please, Kirsten. We like to think about this as starting early and starting all the way through the project. There's been a lot of emphasis recently on specifications and things that we can do right at the tail end or just before it goes to bid. But the biggest impact that we can have is when we start early and involve the whole team. And the first step in that is understanding what's the baseline and what are we trying to reduce. Any reductions are great reductions, but we have to know what the goals are. And then as both Chris and Baha mentioned, it's understanding what are the worst offenders in your project. What are you going to target? And unfortunately, structure is a big piece of it, right? I mean, we're a big piece of the embodied carbon pie right now. So we as structural engineers, we have a larger responsibility to make reductions and get creative. And then during design, I'll walk through some of these, but look at the materials, right? You can't always compare, you can't compare apples and oranges. So you got to look at more of a life cycle assessment for, is the whole building concrete? Is it steel? Is it part steel, part concrete? Is it part steel, part timber? Is it all timber? And look at the drivers overall. What about the architecture? What about the grid? What about floor repetitiveness? What about the loads imposed? And then the efficiency of the structure, and then into the specifications. What can we do to reduce the embodied carbon of the materials that we've shown in the documents? And then it moves on to procurement and finding trusted partners and contractors and subcontractors willing to get out there and get creative and who have the materials that we need. And then continuing to track during construction. Next slide, please. So one of the things that illustrates this is that there's different responsibilities, and I'm being in DC, right? We're a concrete town, so there's just a lot of emphasis on concrete. So I like to show this slide just because, again, there's been this emphasis on specifications, but there's so much on the design side that we do. So if we're at a baseline, let's say we understand what the baseline is, that's a challenge already. But if we understand what the baseline is and how to and what our reduction target is, if we go through design and make certain decisions, then we get to the point where we can ask the supplier to make reductions, but we've already elevated the overall GWP of the structure, and we're starting from a worse off place. Whereas if we start early and we're coordinated with the team and we're aligned with owners' goals, we can make significant reductions versus comparable buildings in our region before it even gets to the supply chain. So next slide, please. And one of the first things we need to do is understand where the majority of the embodied carbon is within the structure. And so this data that's on the screen is from TT's 10+ years of tracking embodied carbon in structural projects. But the biggest thing that I'd like to point out is that if you combine the last two categories there, floors and structural framing, they really go hand in hand. It's the horizontal elements of the floor systems. That's like 60%, you know, between 50 and 60%. And for typical commercial office building, it's 60% of the embodied carbon in the structure. So that's a target for us, right? Whatever reductions we can make in floor framing and floor slabs has a much bigger impact. Next, please. And then Chris and Baha went through just great information about life cycle assessments, and from a structural standpoint, we think about this, we take it to a little bit more of a simplified level and just looking at the structure early on. So early on in a structure, when you're evaluating what materials to select for the structure, every project goes through this, right? It's let's at a concept level look, is it a concrete building, is it a steel building, and now, you know, in some cases is it a timber building, and there's always the evaluations of, well, what does a steel building do to our headroom, or what does a concrete building do for improved schedule, or what is what are the costs, relative costs, what are the familiarities of the contractors. And now we're starting to see more and more that's being layered into that is this life cycle assessment of the carbon footprint of those structures. So it's not the kind of thing where we can, early in concept of a project, when the owner is making decisions and getting input about what's the right material to use, we can't just pull out an EPD for concrete and say, well, we would typically use a 6,000 PSI mix for a slab, and then let's pull out a EPD for a steel beam or a composite slab on deck, and then let's pull out an EPD for CLT timber decking, and make that comparison and make real decisions based on that. It just doesn't work that way. We need to look at whole bays, at least bays and buildings together, from an very early standpoint, and those whole building assessments need to form part of the decision tree on what materials to use. So next, please. And then as a structural engineer, I'm always worried about loading and what loads to use, what's required by code versus what is common in the region, what's demanded by the owner, what's expected by tenants. Recently in the DC region, we've seen a push on retail establishments. Retail tenants want 125 pound per square foot live load, not 100. Maybe they're asking for 150. Those kinds of decisions, 125 PSF live load versus 100 might mean an inch on your slabs. Similarly, in the DC region, there's a lot of pressure to provide, you know, office floor live loads of 100 pound per square foot to have flexibility for GSA, and you know, that's not required by code. Code loads are lower. So there's a lot that we can think about with loading. Whatever we can do to optimize and reduce loading, if it maintains the flexibility of the building and the resilience of the building for future purposes, we're going to get thinner slabs, lighter beams, smaller columns, fewer shear walls in a seismic region, and smaller foundations. So if we can optimize the requirements on the structure, then the carbon footprint goes down. Next, please. And one of the other aspects of this is the design of the building, the architecture, the other drivers that drive what the structural framing systems are. I show this slide not thinking that we're ever typically especially in our region, going back to 20 by 20 office grids. The typical now is 45 by 30 or something like that. But there's a clear difference in the carbon footprint of smaller spans. So you can see this is a 1970s 20 by 20 office grid. The slabs are thinner. The grade of concrete is lower, and versus a 2010s much more aggressive floor plate. There's a 30+% difference in the carbon footprint per square meter in those systems. Next, please. And this is a more typical comparison that is going on a lot these days in the DC region. Is if you've got maybe it's 44 feet column to column to give you 45 feet from the core out to the face of glass. If you clear span that, it's nominally a 12-inch thick slab, post-tensioned. You might have capitals, you might have drop panels, or different systems that can be used. But let's say for this example, you're just using a 12-inch thick slab. If you can find an optimal solution to pull those columns back from the window, depending on what the layout of the office is, if there are offices at the perimeter and you pull that column back into a partition, or if it works with potential tenants, you cut the span and you have this cantilever on the outside that balances things out really well, and maybe that's a 10-inch slab. Maybe you push it to 9, and you automatically gain these reductions. A side benefit that I didn't list on here is in DC, we've got every building has 3 or 4 levels of below grade parking. And in every case for this 44-foot span on the left, once you get below grade, you're dropping intermediate columns to cut the span down so that you've got more efficient parking slabs. And those create more columns and more foundations. If you can go with the system on the right, you don't drop in additional columns and footings. And you get some, not only do you get those savings in the carbon footprint because you're using less concrete in the floor slabs, you're reducing your foundation sizes as well. So next, please. Material efficiency is something else that, from a structural engineering standpoint, we always are aiming for anyway because it lowers cost. But that whole equation is sometimes thrown into disarray, I'll say. What we have on the left is an example from 1930s DC construction. I've been fortunate enough to be involved in a few renovations of some of the historic buildings that we have around, and this is a system that was common in the 30s. It's a one-way concrete joist system with terracotta infill, and it was very labor intensive but very materially efficient. On the right is a typical condition that we're being asked about a lot in parking slabs. Can we just go to a 12-inch constant thickness parking slab instead of what's shown in the lower right, a more typical 9+6 or 8+7 type of parking slab, which requires more formwork, a variation for drop panels and things, but is a lot less material. So there have been cases in the past where it's been proposed by contractors to go to this constant thickness slab, which speeds construction or may speed construction, may be lower cost in the end, but obviously has a larger carbon footprint. So next, please. And then tracking and evaluating, Chris and Baha again did such a great job talking about the whole building life cycle assessment. And from a structural standpoint, we track it as early as we can. We start evaluating as early as we can in concept design and schematic design. And then we have a tool called Beacon that is a free, anyone can go and download this, type in Beacon into Google, and you can download this as a plugin for Revit. And with a couple of clicks of the mouse, you can take a structural Revit model and input some parameters. It uses standard parameters, average parameters for the US, but you can input your own GWP values. But it'll tell you what the carbon footprint is of your structure. So then any changes you make in the Revit model, you can iterate. We have processes internally that can take us from different models into Revit and back and forth. And so there's this feedback loop that we as structural engineers can and should be making, taking advantage of to reduce the carbon footprint before we even get into the specification part of the project. So next, please. So before I jump into, I was going to jump into concrete considerations, steel and timber, but I do want to emphasize that what we're talking about today is very high level. I'm trying to go through some lessons learned and some considerations, especially from the standpoint of a structural engineer, that we're looking at as we're trying to reduce the carbon footprint of our structures. So you know, Thornton Tomasetti is one of the signatories of SE 2050, and we've got commitments that we're trying to make internally. And then we're obviously, our clients, architects like ZGF, developers, all of our other, you know, trusted partners in the region, they all have requirements as well. And what we're seeing is that those are coming out in RFPs and other things. So there's a lot to this topic of reducing the embodied carbon in the structure and what the strategies are. So this is it's a very quick sort of high level introduction, and I think the intent is that as we continue events for our chapter here, that we'll get other speakers from other firms and maybe even other industries, and from our producers and suppliers to speak more to each of these topics and other topics, so that we can all learn from each other. But concrete considerations, I'll go through these quickly. They're on the screen, but it becomes a lot of allowing the mix designers a lot of creativity and removing sort of prescriptive requirements where we can, and being open to new technology. That's one of the things that is hard for us as structural engineers sometimes to deal with. Is we like the status quo. We like things that have been tried and true, and that we've got a long history of, and we usually need some convincing to try something new. And but there are great products out there, you know, things like Carbon Cure and Type 1L cement that's becoming more common, the concrete maturity method that's in use, things like that can make substantial reductions, even above or in addition to just cement replacement and reducing cement. Next, please. Steel's a tougher one in some respects. There's not as many levers that we as structural engineers can pull. We can't ask a steel producer to hit a GWP target necessarily. You know, steel production comes from a limited number of mills in the country. But what we've had a team within our company doing basically an internal research project for a year, and some of the output of that is that we as designers, of course, need to optimize tonnage and understand, and maybe it's not necessarily always optimizing tonnage, because that might mean more pieces and that has cost implications and other things, but thinking about, again, being efficient with our tonnage. And some of that comes back to the grid or loading. Prioritizing domestic steel is one of the biggest things I think that structural engineers can try to influence. Most of the U.S. steel comes from electric arc furnaces and has very high recycled content, and has a much lower carbon footprint than some foreign-based steel that we get. And next, please. And then timber. Timber is almost its own animal here. You know, we still have to evaluate timber against other materials, and timber is great, but it may not always be. It's not always going to be the right fit for a project. It might have the lowest GWP in a lot of situations, but that doesn't mean that's going to be the choice of the owner. And so there are timber projects happening in our region now, which is really exciting. There's more and more acceptance to using mass timber. I know there's an overbuild down at 80M. There's a project in Arlington that's got a mass timber component to it. The photo that's on the screen there is a TT project out in Wisconsin. that is, it'll be the tallest mass timber structure in North America, but there are considerations to mass timber. We need, what's the EPD? Are they prioritizing wood products from climate smart forests? And as much as we can prioritize locally sourced products, the better. So all these different materials have somewhat unique considerations, but the one aspect that was common to all three was we need to ask for EPDs. We need the information to help the industry have data to make decisions and to grow the database to reduce. We have to know where we stand before we can reduce in terms of embodied carbon. So with that, I'll close and would like to just say thanks for the opportunity to share some of those thoughts.
Great, thanks, Michael. That was a great overview of some of the strategies and considerations that we should all be looking at in terms of our structures and how to reduce our embodied carbon. And some great presentations by Chris and Baha as well. I guess we're going to open it up to some questions, but just before the questions, I do want to just mention our upcoming events. Like I said earlier, we do have an event upcoming on July 22nd. It's a Thursday, and we're thinking maybe more in the morning this time, maybe 9 a.m., 10 a.m. around that time. And just sort of like an open networking discussion. We'd love to meet all of you, kind of just talk through some things, you know, anything in your own projects that you're struggling with or have questions with. We'd love to talk through it and just meet and get to know you. And for August, we are thinking of doing an event on different cement types, the uses and reducing impact associated with cement. So just stay tuned for that. That will likely be in August with the date to be determined. So with that, I guess I will open it up to some questions with the experts. Feel free to turn your video on and unmute and just ask any questions that you might have.
Hello, are you hearing me?
Yeah.
Hi, let me lower my hand. First of all, thank you so much for that great presentation. Great graphic presentation, and then great explanation for the case study, workflow, LCA workflow, and then also about the structure and then the reduction. My name is Negin Sharifi. I am in Seattle with MG2. I am co-lead for embodied carbon reduction for my company, PAE 2030 commitments. I am working, or I have been working on case study. I don't know who is going to answer my question. I'm asking just questions. Mm-hmm. So I've been working on a case study. This is one of our pilot project to report. And then, you know, talking about mass timber versus metal building system. And then, you know, these days just people are really advocate about the mass timber, and I know about the importance of that. The study that I did, I used Athena. Of course, Athena doesn't show the sequestering part of the, at least I couldn't find any area of when you use Athena for LCA. My focus was on a structure and envelope of a building, like metal building system, having like just a stud wall, wood, like a steel stud wall, and then a metal panel, versus having wood panel and then bearing wall for the mass timber building. So the study basically turned out as a result of Athena study in basically earlier stage in A1 and A2, A3, which is product area. I got reduction in on GWP on mass timber. However, in the whole LCA, when you look at different stages, especially when you look at that area of operational carbon, because I had added a couple of information to use that. So the mass timber was higher. And then I know about the installation and then all sort of the things that we are using. I wanted to know if you have happened to have that issue, because we are thinking of, okay, so shouldn't have that much of like that much like higher like operational energy, or not operational energy, basically yes, operational energy higher than in mass timber building versus like metal building. Just question about that. Just wanted to have your input. Thank you so much.
I'll take the first swing at this and say that your experience in terms of potentially seeing or hearing wildly different things about the carbon emissions or sequestration of timber are, our experience, and I think are all through the industry. So we're all still figuring that out, right? And we've noticed too, depending on the assumptions, particularly end of life assumptions, in mass timber, it can wildly swing, wood from being a sequestering option to an emitting option. It's very complicated. I will also say, ZGF has been working on this in our LCA work, and for a large project that we're doing with a lot of mass timber components, and are very close to, I don't think it's been released yet, Baha, you correct me if you know otherwise, but we'll have a tool called Upstream that's looking at all the factors having to do with wood life cycle emissions, recognizing that the two big questions are the end of life. Is the wood landfilled? Because if it is, it's decomposing and giving off carbon or methane, but also just as important, or arguably even more important, is the forestry practices at the beginning, because not only are the trees sequestering carbon, but the forest and the soils are too. And so we've seen data, and what Upstream will reflect are practices with FSC sourcing or more sustainable sourcing that can sequester timber. So I'd say it just in general is a big question mark. I mean, we're using that sort of disparity to at least talk to owners about sourcing sustainable timber. I just got an email about FSC being really hard to procure right now post-pandemic, and also about thinking about wood end of life and how we can detail mass timber buildings to make wood reusable. So yes, absolutely, we're seeing the same things, and I believe, and maybe either Michael or Baha can talk to maybe some of the databases and their different assumptions for wood carbon emissions.
Thank you, Chris.
I could also, not necessarily to answer your question, but just to add to the challenges, when one more challenge, when you compare, let's say, a wood structure to steel or even concrete, the reductions in carbon are more still challenging, but straightforward. But there are other categories like eutrophication that could be impacted, where a natural material might have a higher impact in eutrophication, or ozone depletion, because the numbers are so small, could considerably shift in the wrong direction. So these are definitely challenges with LCA, but I know LEED is trying to respond to some. For instance, ozone depletion, you could round it to 4 significant figures, which would make it 0 for many applications. So you don't see a change, but there are definitely challenges.
Thank you.
Sure.
Okay, hi, can I go for the next question?
Yeah, of course. Go ahead.
First, I'm Nikki. I'm a Master of Science student at the University of Oregon. I'm working on, the thesis I'm working on is about the embodied carbon in concretes and some also about moisture in concrete. But it was so unfortunate that I arrived late. Sorry, I'm in Virginia in Charlottesville, and I had a test, and I went there, and because it is super rainy here, it got canceled. But I was lucky enough to quickly come back and make it at least to the last presentation. So I saw the presentation by Michael, and I had a question from him, or anyone who can answer me, that would be great. About in a slide about concrete consideration, Michael, you had put the last item was allow longer cure times where possible. Could you explain more about it and why?
Sure. Some of the typical areas that we would normally allow a longer cure time would be foundations, columns, shear walls, things that you don't need the full strength right away. To contrast that, floor slabs, right? Floor slabs, especially in this region, contractors are looking to stress a slab in 2 days, strip it the next morning, and then move on with the floor. And so you have to get up to a certain strength to be able to stress post-tensioning, strip the formwork, reshore, and then build your next floor. And so much of the cost of construction is how long is your schedule. And so if you can condense your schedule or keep on schedule, then your costs are in check. But what we see is that we can't always lengthen the cure times for the floor slabs and for horizontal elements, right? Those need to come up to strength pretty quickly to allow the stressing and the stripping of formwork to continue. But vertical elements like the foundations, columns, we don't need a 28-day. We don't always need a 28-day compressive strength. Those could be 56 days. They could be 90 days. Foundations they're typically going to be 56 days anyway, because especially for mass concrete, if you have a thick enough foundation, it becomes what we call mass concrete, and the heat of hydration and everything that goes into curing that concrete can cause cracking that we don't want. So we would normally add a lot of supplementary cementitious materials anyway to try to reduce that heat, and that gives you a slower, longer cure anyway. So some of those tricks that we can use to reduce the carbon footprint of those elements, it's almost we're doing that in some ways we're doing that already, but on some projects we need to specify that this is acceptable, or to hit the GWP targets that we want for these elements, use a 56-day cure, use a 90-day cure. It's acceptable from a structural standpoint. Now, there are other considerations that the concrete sub is going to use in terms of, well, what strength do they need to be at to strip formwork, or what strength do they need to be at to finish? Are there architecturally, are there any aesthetic concerns with waiting to strip, or with stripping too early, that finishing, and there's a lot that goes into it. But that's part of why, especially for concrete specifications and mixed designs, it's better to allow that creativity from the mixed designer where we can. Did that help?
Yes, thank you very much.
Yeah, sure.
It looks like there's a question in the chat as well from Mer. Would you like me to read it, or do you want to ask it? All right. Do you, as part of the design package and whole building LCA, discuss with the tenant about provide strategy for embodied carbon through building operation. This is mainly related to commercial buildings with lots of tenant improvements. Anybody want to address that?
Yeah, I'll jump in. I'd say it's yes. Ideally, we are talking. I mean, I'll be honest. I think our process, and I think everyone, we're still learning how to do this. And we actually have a lot more practice with structure and envelope, and we're starting to look more at on the TI side. So again, we talked about that residential project where we're focusing on it. We're certainly aware of it. And talking about it in some office projects, in medical office buildings, because there's a lot of churn there as well. So a lot of times, we do core and shell and speculative work, and in those cases, that it's oftentimes another design group or another design effort to do those. So it's evolving, I think, and I would also encourage folks and firms that are getting involved in this. It can be overwhelming because everything has a carbon footprint, and but choose those areas where you can make a difference, and that seem to be significant, and continue to expand that effort. And we need to move fast, but we also need to get involved and see successes too. So we are doing it. But not yet holistically. But I think one of the things we're doing is developing those details and those wall assemblies that we know are lower. And if we can get those kind of as our standard sort of design approach, then we know we can make impacts throughout our portfolio.
I have more question if I'm not taking place of anyone else.
No, go ahead.
Okay, thank you. So regarding earlier stage LCA, so when we start very earlier stage, I know how much like it's data in, data out. That's basically whatever that data we get to the software, the result would be that accuracy of what we insert at the first place. So when we wanted to talk to client, especially one of those couple of those tough client that they are really not advocates for what we are doing, and then we wanted to show them sort of their results or basically the impact in reduction on some sort of the area, those really our goals of for example, envelope or flooring or something. How much detailed information, especially for assemble, wall and roof assembly, I would say, just specifically, because I know there are a lot of impact into these two areas. How much of detail on the assembly you start at the really earliest stage? Do you ask? It's because we are architects, so we usually ask our maybe clients in this design package that they work with their structural earliest stage, or we ask as consultant of our structural engineer or something to put together based on the concept or idea. And then I remember during that presentation you started with having a small a study, not really big one, just focus on the small. And then my understanding is from that is you are asking, for example, if even that consultant, a structural engineer, doesn't give you the whole story, just give us one a wall section, and then giving us, okay, so we have that sort of detail, that much detail of to start with. What is your approach for that? That is really important for me.
Yeah, I think what you're suggesting is when you're looking at a wall assembly or roof assembly, I mean, you could be looking literally at just 1 square foot of wall, right? Like the assembly, or you take 1 bay of a wall, right? And what I've been amazed with Tally is that it's actually really easy, because you're not even with Tally, you're not even drawing those layers. You're literally just specifying it to the Revit model. So we've done studies and it's really, really quick. You could just like literally pick a wall and say, okay, that's a 2x6 stud backing. It's got this type of insulation. It's got this type of cladding, and you could, you know, you've got an LCA model for that element in a couple minutes, and you could kind of compare it to a couple different options and look. And whenever we see differences, you can have an interesting conversation with the entire design team about like, look, this wall was good for this, but maybe it's not so good on global warming potential. Can we do better? And you can also use the data to kind of point out what's really driving the impact, whether it's the cladding, the insulation, et cetera. So totally viable to do that small.
Sorry,
yeah.
sorry to interrupt you. Sorry, I know it's tough. It's kind of like limited time. So talking about the cladding, that's a good point. So when you start, you wanted to ask about what type of cladding is, because I know, for example, PVC cladding versus like metal cladding or some other cladding will have huge differences between what we get as a result of GWP. In terms of, so you won't go with assumption very early stage, or you have at least, you know, that client, so you know that, okay, so client is going to be with metal building or masonry or the other type of cladding. So these three cladding, and then you go and then you start your research with these three type as sort of like templates, if you know that client.
Yep, you could just build them up, like literally if it's a choice between those three options, we could just literally have a, you know, essentially a wall or different design options for those three different walls and be able to compare the three. And you don't need to, you know, if that's really the choice. Now there may be, if you choose one wall, there may be a different structural backup or some other, so you want to make sure that you've got enough of a model that has all the fundamental differences. If one of the walls requires something different, you know, you want to be able to reflect that in the model or be able to take, you know, that, and that may happen in Tally, or that may happen when you export the results into Excel. If there's a different, you know, or for some reason, if there's increased structure or something, you may need to get that. It may need to figure out how to scale the data, but it's very easy to kind of create, you know, and if you know, my building has whatever I choose for cladding material, you're going to have the same amount, 50,000 square feet of wall area. Well, then everything's going to scale equally. So you just compare it on, if that's just that choice, just make the simplest model you can that represents all the differences. It's pretty easy.
Thank you.
I was just going to add, I know we're towards the end of our time, but one more quick point about cladding. Make sure that you include the whole cradle to grave, because a cladding system that lasts, let's say 10 years, and it's low impact, or something that lasts 30 years, and it's a little higher impact, you know, you just want to make sure that you have a larger life cycle to account for maintenance and replacement.
Yes, that's a good point. Great point. Thank you so much.
Sure.
All right. Awesome questions. And thanks everybody for joining today. Thanks so much to Chris and Baha and Michael for their great presentations. There was a lot of awesome information included in there. So we are recording this webinar, and we'll post to our website. If you have any questions or have any suggestions for future events, please feel free to email us or contact us through the website. And otherwise, we will see you in July.
Thank you so much.
Thanks, everybody.
Thank you.
Thank you.